Well, for this recording, we're going to be talking about analytical geometry. Okay, so at its core, analytical geometry it's where algebra and geometry meet. Okay, where algebra and geometry meet. So we are trying to apply algebra to geometrical shapes on the Cartesian plane system. Okay, so you should be familiar with the following key concepts here in analytical geometry. Coming from level 2, you should know how to calculate the distance. You should also know how to calculate the midpoint, right? So the distance is just basically the length or the distance between 2 points along a straight line, and then the midpoint is just that point in the middle, the midpoint, right? The center point on a straight line. So let's say maybe you have something like this, a straight line, A, B, right? So a midpoint would be a point that is located somewhere in the middle of the line AB, making this to be equal to this. Okay, and then you should also know how to calculate the slope or the gradient, which is described as the change in y over the change in x. And you should also know how to find the equation of a straight line. So the equation for a straight line, we use this or this to get the equation for a straight line. Any straight line, provided you have some information. Okay, so but for this recording, we're going to be focusing on the first 3 points, right? You can look at this discussion as a recap to some of the basic concepts, key concepts here in analytical geometry. So let's take this away, and bring in this. I'm also going to have a Cartesian plane that I prepared for our discussion. Okay, so here I have an activity from 1 to 4. We're not going to do everything here. Né? What I'm going to do for the first one, I'm just going to pick A, and then for number 2, I'm also going to do the same, pick A, and then for 3, do the same and pick A. Number 4, for the last one, I'm just going to pick A as well. Okay, so so each question it talks about the key concepts. Like for example, number 1, it talks about distance. So I'm going to show you how to apply the distance formula. Number 2 also talks about distance, but how in the context of how you can apply it in analytical geometry in other instances. Then number 3, we're going to be finding the midpoint, and then number 4, we're going to be calculating the gradient. We're not doing every question here. We're just going to pick one for every question. So for number 1, it says here, determine the length of the line segment joining each pair of points. So for number 1, we can see that we are given a pair of points. Yes, a pair of points. So we are given point A, which is 1 and minus 4. So 1, so 1 is here, and then minus 4, it's 1, 2, 3, 4, minus 4. This is point A. It's the coordinate 1 and minus 4. And then the point B, it's minus 2 and 7, minus 7. 1, 2, and 7. This is 5, 6, 7. This is point B being what? minus 2 and minus 7, minus 2 and minus 7. Let's connect the 2 points. It's line segment A to B. So they want us to calculate what? The distance. So they want us to calculate the distance or the length. So how do we calculate the length? We're gonna say length AB is equal to the square root of xb minus xa squared plus yb minus ya squared. Just make sure that if your x has been subtracted by a, so if you said xb minus xa, and then for the y coordinates you're gonna have to do the same thing. Start by a and follow it up by you're gonna start by b and follow it up by a. And if you said xa minus xb, you should do the same thing even here, ya minus yb. Okay, then we substitute square root of what is xb, it's the negative 2, minus xa, it's 1 squared, plus yb, that's negative 7, minus ya, it's that negative 4, minus 4 squared, equal to, then we calculate the whole thing. It's the square root of minus 2 minus 1 squared plus minus 7 minus negative 4 squared. The answer is going to be 3 square root 2. So this is the distance between A and B. So let's jump to number 2. But first, let's start off by plotting the points. So they want us to determine the perimeter. What is the perimeter, by the way? So a perimeter, let's say I have a shape like this, which is a rectangle. Then this side is 4 centimeter, this side is 2 centimeter. So the perimeter for this shape, it's gonna be the distance around the shape. So the distance from here to here, then from here to here, then from here to here, then from here to here. They're all gonna get added, and then the length we get is called the perimeter. So the perimeter for this shape is gonna be the 4, this 4 plus the 2, this 2 plus another 4. Remember, opposite sides of a rectangle are equal, so it's going to be another 4 plus a 2 centimeter plus a 2 centimeter. So this is 8, 10, so the answer should be 12 centimeter as the perimeter. Okay, as the perimeter. So that is what we call a perimeter. But here we are given a triangle ABC with vertices A. Let's plot A, 2 and 3. 1, 2, 1, 2, 3. This is point A, which is 2 and 3. And then we have B, 3 and minus 2. 1, 2, 3, minus 2, 1, 2. We have B, 3 and minus 2. And then C, 1, 2, that's minus 2, 1, 2, 3. That's point C. Point C, minus 2 and minus 3. Then we connect everything. A connects to C, C to B, then B to A. So they want us to calculate the perimeter for this. The first thing I will have to calculate would be the lengths between A, B, the length between C and B, the length between A and C. After getting these distances, then I'm going to add them, right? So we're gonna start by finding length AB, which is the square root of XA minus XB squared plus YA minus YB equal to the square root of XA, that's 2, XB, that's 3 squared, plus YA, that's 3, minus YB, that's minus 2, put it in brackets, squared. Then we calculate, and then we calculate, we get a 2 minus 3 squared plus 3 minus negative 2 squared. No, I need to put the bracket here, squared. So the answer is square root of 26. Okay, then we're gonna calculate AC next up. So it's gonna be XA minus XC squared plus YA minus YC squared. Then AC is equal to the square root of what is XA, that's 2, minus XC, that's negative 2 squared, plus YA, that's 3, minus YC. What's the point C? Oh, it's negative 3. So it's gonna be a minus 3, then we square this. So it's gonna be the square root of 2 minus negative 2 squared plus 3 minus negative 3 squared. Wait, syntax, what is happening? What did I do? Oh, I didn't open a bracket here. So the answer is AC 2 square root 13. 2 square root 13. Then I'm gonna calculate BC here. So square root BC, BC is equal to the square root of XB minus XC squared plus YB minus YC squared. So BC is gonna be equal to XB, that's 3, minus XC, negative 2 squared, plus YB, negative 2 minus YC, that's negative 3 square. Then BC is equal to, let's calculate. So it's gonna be a 3 minus negative 2 squared plus negative 2 minus negative 3 squared. Answer square root 26. So now the perimeter is gonna be what? The perimeter is gonna be the sum of this and this and this. So you're just gonna add all the sides. Square root 26 plus square root 26. This plus this plus this. Square root 13 is gonna be equal to 2 square root 26 plus 2 square root 13. So the answer is gonna be what? Let's get the final answer in three decimal places. Let's say that square root 26 plus 2 square root 13. Answer 17.409. So this is our final answer. This is how you get the perimeter. For the next one, 3. They want us to calculate the coordinates of the midpoint joining the 2 points. So here I have A and B. I have to find the midpoint between A and B. So point A, it's 1 and negative 4. This is A, it's 1 and minus 4. Let's plot B. Minus 2 and negative 7. It's this one. this is b minus 2 minus 7. Connect the 2 points, it's a and b. So we have to calculate what? The midpoint. So the midpoint is calculated as midpoint with coordinates x and y. This is equal to the midpoint of a plus xb over 2 ya plus yb over 2 m over what is xa, that's 1 plus xb minus 2 over 2 ya, that's minus 4 plus yb, that's negative 7 over 2, close the bracket. So m is equal to, let's work out the first coordinate. 1 plus, it's 1 plus minus 2 over 2, so the answer is a negative half. And then for the y coordinate, that's minus 4 plus negative 7, close bracket, over 2. Answer, that's negative 11 over 2. So this is our midpoint. Now for the last one, calculating the gradient. Calculating the gradient, number 4. Okay, same points as above. So it's 1 and negative 4. That's a. 1 minus 4. And then we have b. B, that's minus 2 and negative 7. It's this one here. B minus 2 and minus 7. Then you connect the 2 points, a and b. Let's calculate the gradient between these 2 points. So m, the gradient is represented by what? By m. M, gradient between a and b, is calculated as a minus b over xa minus xb. So what is ya? That's negative 4. Minus yb, that's negative 7, over xa, that's 1, minus xb, that's negative 2. So the numerator is going to be a minus 4 plus 7 over 1 plus 2. Negative 4 plus 7, that's 3, over 1 plus 2, that's 3. Answer is 1. So take note here that the gradient came out as a positive value, right? So whenever your line is slanted like this, it means that your gradient is going to be positive. But if your line is slanted like this, your gradient is always going to come out negative. So these are the basics for the key concepts here in analytical geometry. So check the description box for more topics I have discussed for the analytical geometry, or how to find your straight line, how to find the equation for a straight line, how to work with parallel and perpendicular lines, what else to do. You know what, just check the description box. I've discussed the other topics that are relevant, or topics that you should know, or other concepts that you should know when it comes to the analytical geometry. So guys, thanks for tuning in. I'll see you in the next one.